In this video, I will talk about inverse functions, and I will also talk about some examples relevant to inverse functions. So this is actually section 7.1 for the Thomas calculus of the Thomas calculus. So let me just start inverse functions, and we will do many examples so that we will understand the concept of inverse function. If you know that, suppose we have two, example, if we have two, the reciprocal of that 2 is 1 by 2, which makes the answer 1, which means that these two are reverses, these two reverse the effect of each other. This 1 by 2 is the inverse in real numbers, but we will talk about inverse in functions. So what f, and suppose if we have f, the inverse is f inverse, and these two reverses the effect of each other, which means that if we apply these together, we get, for example, some other quantity which is the domain of these two functions. Let me just start from an example and generate a table out of that. Our first example is f of x is equal to x cube, and suppose the inverse function is f inverse x is equal to x raised to power 1 by 3. Suppose this is our inverse. We will talk about uh, how to find this inverse. Currently, let me just explain the idea first. Let's generate a table over here. Our table contains x and the value of x and f of x. Suppose x is equal to minus 2, and remember that f of x is x cube. When x is equal to minus 2, we will get minus 8. When x is equal to minus 1, then we get minus 1. If x is equal to 0, then we get the value of that function equal to 0. And we continue like that. For 1, we have 1. For 2, we have 8. And for 3, we have 27. This is the table 1. Now, let's make another table for the function, inverse function. Suppose we have x, same domain x, and we will talk about that, why there is an x over here. And f inverse x is x raised to power 1 by 3. When x is equal to minus 8, now what we are doing, we are giving the value of this range. This range has minus 8. Since remember that these two look similar, but they are not similar. We will talk about that. Just wait for a moment. So when x is equal to minus 2, and when we put that value into the inverse function, so we have, for example, f inverse minus 8 minus 8 raised to power 1 by 3, then we have minus 2. So what we are doing, we are moving from the function value to the uh, domain value, from range to the domain. This is domain to the range, and this is range to the domain. Although it looks like this is x, but this is not x, this is actually a y. Okay, this is not a mistake. We will talk about that. When we have, for example, minus 1, when we have minus 1, we get minus 1 in inverse function. When we have 0 in the x, then we get the inverse answer is 0. So we can see that the from domain to range, we have this table over here, and from range, from minus 8 to inverse function, we have this value over here. Okay, now let's take an very simple example, and we talk about the role of f and f inverse. 2, when we have 2, for example, and we put that value 2 into x square, then we get 8, right? When we have, for example, 2, then we get the value 8. When we put that value 8 into x raised to power, it should be 3, I'm sorry, and this is 1 over 3. When we put that value 8 into x raised to power 1 by 3, we can see that the value is 2. So it means that these x cube and x 1 by 3 are inverse to each other. If we have this f, this is f inverse. So when we multiply x cube, x 1 by 3, then we get, for example, this is, I will talk about that. This is f and this is f inverse, so we get 2. Similarly, if we have, for example, 8, and we put that 8 value into x raised to power 1 by 3, then our answer is 2. And from this 2, we can write x cube. If we have x cube, we put that value 2 into x cube, and the answer is 8. So we can see that if we move from x cube to x 1 by 3, we reach at the same point. When we move from x raised to power 1 by 3 to x cube, and we take an input as 8, then we reach the same value as 8. So what is the definition of this? What definition becomes from this explanation? So the definition is, I write the definition over here. Suppose that f is one-to-one function, one-to-one function on a domain D with range R. The inverse function f inverse is defined by if F inverse B is equal to A. This is only possible if f of A is equal to B. So this is the definition of inverse function. There is one very critical condition for inverse function, and that condition is one-to-one that we already discussed in previous video. So one-to-one means that if we have a set A and there is another set, for example B, then one-to-one means that for each input we have a value available in B, and this is unique value. For second value we have a value exist uh, in set B. Why one-to-one function has a why there is a requirement of one-to-one in inverse function? The condition is when we move from here to here, then we can move back from range to the domain. If the function is not one-to-one, then you cannot move back from range to the domain. So that's why we must have one-to-one function. Okay. One important note is due over here. Remember that F inverse doesn't mean that we are talking about 1 over F. Usually when we have 2 raised to power minus 2, we say that it is 1 over 2 raised to power 2. But in that case, F inverse is not the power, it is the inverse function. It is the inverse function. Okay. The example I have given in the beginning, it was like that: 2 cross 1 over 2, 2 cross 2 raised to power minus 1. This was just a number. That's why we could have written this as 1 over 2. But when we have a function f and f inverse, then this f inverse cannot be written as 1 over f. This is inverse function. Now we want to learn how can we find the inverse function. So example 1. Example 1. Show that f of x is equal to 2x minus 18 is invertible. Invertible means that it has inverse. Invertible, what are the domain and range of f inverse? So we convert the function f of x into f inverse solution. So what we do, suppose we have, in this case we have y is equal to 2x, y is equal to 2x minus 18. We solve this equation for x. Then we have y plus 18 is equal to 2x. Then we have x is equal to 1 over 2y plus 18 over 2, which becomes 9. So this is our inverse function. Since y is equal to f of x, y is equal to f of x, then x is equal to f inverse y. This is f inverse y. So x will be equal to f inverse y, which is 1 over 2y plus 9, right? So this was equal to x, right? But we in mathematics usually write this function in terms of x only. It is just for convenience. Otherwise, this is just a inverse function. So we replace this y with x, and this y with also x over here, and replace this x with y. So this is just a convenience. Y is equal to f inverse x is equal to 1 over 2 x plus 9. So this is the actual inverse function we have. I will draw that function for you. Either this inverse function is correct or not, we just have to take a composition of these two functions. F inverse f function of x, then f inverse, what is f of x? F of x is 2x minus 18, and when we put 2x minus 18 into f inverse y, we get 1 over 2. Replace this y with 2x minus 18, or this x with 2x minus 18. So we have 2x minus 18 and we have plus 9. We can solve that over here, so we get x over here. So the answer of f and f inverse x should be equal to x, this value over here. Similarly, if we talk about f and f inverse function of x, then f inverse x is equal to 1 by 2x plus 9. This is the value over here. That's what we have over here. And we put that value into the function f of x. What is f of x? This is our f of x. We replace this x with the input. So we have 1 by 2 x plus 9 minus 18 is equal to x. Again, we get the x. So f and f inverse f will be equal to x over here. That is the verification. Now the question is how these functions look like visually. So we plot this function first, and then we plot this function, which is the inverse function. First we plot y is equal to 2x minus 18. Suppose we have x-axis and y-axis. This is x, this is y. And we have 2x minus 18. Y is equal to 2x minus 18, which has an intercept of minus 18. It is not up to the scale, but we just want to learn how this function look like. And it has a slope of 2. And on x-axis, y is equal to 0. So we get 2x is equal to 18 and x is equal to 9. So it should pass from 9. So we have this function which was the given function in this example, y is equal to 2x minus 18. In the next case, the inverse function was 1 by 2x plus 9. The second function was, that was f inverse x, that was 1 by 2x, x by 2 plus 9. It has an intercept of 9, and suppose we have this intercept over here, and it has the, on x-axis, okay, and on x-axis y is 0, so we have minus 18 over here. So from here we can draw this function like this. This is the function. I can just repeat that. This is minus 18, this is 9, and these two linear function intersect somewhere over here. So this is our given function f, and another one, this is a given function, this is the function that we obtained is f inverse. And these are the reflection of each other at y is equal to x. This is y is equal to x. These are reflection of these from on y is equal to x. Let me just solve another example. Video is a bit longer, but you can skip some of the parts since the video is in chapters in different sections. Example 2. Suppose we have some random function y is equal to f of x, and the table of that y is equal to f of x is x, 1, 2, 3, 4, and 5, and f of x is 3, 4.5, 7, 10.5, and we have 15. This is the table for y is equal to f of x. And if we want to find the inverse of that function, then x is equal to f inverse y. So what we do, we make x and x equal to y and y is equal to x, y is equal to x. So we have y, and this is f inverse y, which becomes x. You know that in this in the previous example, we already saw that we are happy in mathematics to replace this y with x and x with y. So when y is equal to 3, when this y is equal to 3, we have x is equal to 1. When y is equal to 4.5, so we have 2. When y is equal to 3, then we have 7. Then we have, when we have, for example, sorry, it should be 7 and it should be 3. And this is 10.5, 10.5. Then we have the value 4. When y is 15, then we have x is equal to 5. Okay. So this was an example that we probably repeated the third time, where we understood that when we have x and f of x given in the example or somewhere, and if you want to find the inverse function, then you just have to replace x with y and y with x. Let me just further explain this idea in a graphical point of view. Suppose we have x and on y-axis we have y, and there is some random function y is equal to f of x, y is equal to f of x. So the domain of that function is this color over here. This is the domain. So this is the domain of this function. We call that domain of f. On the y-axis, the value is 0. The first value is 0. Then it reaches up to over here. Then we have the range. Range is this y value over here. So this is the range of f. Range of f over here. Now, if we have inverse function, what happens in inverse function? We're talking about graphical point of view. We have, for example, x over here, then we have y. Suppose we have a function like this, and this is not y is equal to f of x, but it is x is equal to f inverse y. F inverse y. When we had this graph over here, in that case, we move from x to curve, then from curve to y value. That's how things move or explainable in this graph. On the other hand, if we have inverse function, so what happen in inverse function? This value up to this value over here, this one, this line represents the range of f inverse. And on the y-axis, we have this line, and this shows the domain of f inverse. So the role has been changed in this situation. When we had y is equal to f of x, you were moving from x to y and y to x, from curve to the y-axis. When we have inverse function, in inverse function, you move from domain, which is y-axis, to the curve, and then from curve to the range, which is x-axis. So there is orientation difference in f of x and f inverse x. So these graphs, f and f inverse, are reflections of each other on a graph. Okay, so let me just go to another example. Suppose y is equal to, we have y is equal to 1 by 2x plus 1. The question is, find the inverse of y. So the procedure is the same. So we have y is equal to 1 by 2x plus 1. The first thing we need to find out, we need to do is to find x from here, and the x will be equal to 2y minus 2. So this is our inverse function. Now we interchange the value of x and y. X becomes y and y becomes x. So we have 2x minus 2. So y is equal to f of x is our given function 1 by 2x plus 1, and y is equal to 2x minus 2, which is f inverse x, that is equal to 2x minus 2. If you want to check again either these are correct or not, so we apply f on f inverse. So we have, for example, f inverse x. F inverse x is 2x minus 2, and we have 1 by 2, 2x minus 2 plus 1, so we get x. And again, if we have f inverse f, the composition of f inverse and f, so we have f inverse and f of x is 1 by 2x plus 1, 2x plus 1, and when we put that into the function f inverse, we get 2, 1 by 2 x plus 1 and plus 1 or minus 1, minus 1 or minus 2, since we are putting that value into the inverse function. So we get x over here. So these are actually the inverses of each other. F and F inverse we actually found from this example. Okay, let me just draw it for you, graphical representation. We have one function y is equal to f of x, that is 2x minus 2, and another function y is equal to f inverse x, but it is 1 by 2x plus 1. When we have 2x minus 2, then we have minus 2 over here, and this is intercept 1. So we have this function y is equal to 2x minus 2. And another function which is y is equal to 1 by 2x plus 1. So it has intercept 1, and the slope is 1 by 2, and on y-axis x is 0, so we have minus 2. On x-axis y is 0, so we have minus 2. So the answer for the graph for this function is like this: y is equal to 1 by 2x plus 1. If you just want to see the reflection, you can see the reflection is against this y is equal to x, and we already shown that this is inverse to each other. Graphically, they look like this. So this was the another example for inverse function. So the summary of this lecture is, if you want to find the inverse of any function, then you must find the x first, then replace x with y and y with x. Thank you for watching.